Please start.
So hi, we are team 37. And so we are going to talk about the challenges we face in the implementations. And then to implement the value iteration approach, we divide each state as coordinates on the board. And however, the given rewards has a significant impact on the performance. And we found the difficulty of defining the reward for each state. But current strategy is that we set the central coordinates are 10 and 4 corner are 0 and others are 4. And it seems not performs as well as we expected. So the improvement we think might achieve better performance is to give a dynamic rewards, which means that we compare the distance between each current possible action and each previous existing action, and they make a threshold, and the distance within this threshold, then this action will have the specific reward. And this might make the reward more helpful and informative. Next.
And next method, our team trying to approach is MCTS tree. MCTS is easy to be considered as an approach. We can treat the beginning of the game as a node that belongs to the opponent. Then we take this node and expand it. Therefore, the children of this node is regarded all moves we can make. And next iteration will be opponent state again, and so on. In the back propagation stage, we can give negative value for opponent stage, which is the environment. Although this technique is easy to be considered to be applied in the game, however, there are some issues need to be conquered. The first is the precise of the simulation. How to simulate as close as possible to real situation, because we don't know what card in the opponent's card hand. And we might choose a random card from the empty position, and it might work, but still have very high chances that this node will not happen in the game. Therefore, it is hard to predict the trend in the early stage of the game, but it should work better after the mid stage of the game, because the possible moves of opponents are extremely limited. And the second problem is the time consuming for check terminal state. Since we have to check whether each node is the end game, thus we have to read the board every time we simulate a new state. As a result, timeout happening. Although it is a poor model now, and if we find an efficient way to check terminal state and also a reasonable sub-goal to reduce operation load, and it should be a workable method. And next.
In our final tournament agent, we will select the action with the shortest distance between each current possible action and each previous existing action, which means the coordinates of chips. Also, it is based on the closest path to the central grid. For example, if we choose the action A is the next action, but it isn't far from the center of the board, we will reconsider the action A and choose other potential action, which is the closest to the board center and with a certain short length between the current possible actions and the previous existing actions. This is the scenario we conquered the heart of the board. And this one is the second best result of this algorithm. This one is the best result of this algorithm so far. And if this algorithm encounter our opponent has also tend to choose the centroid, this algorithm would choose the closest card to the last card, like this one and this one with a cross. That's all our presentation. Thanks for listening.